Alright, so class, let's start chapter 4. Chapter 4 is on time value of money. Alright, as you can see the image there, it shows money has time value. Alright, $1, let's say 10 years back, doesn't carry the same value as it values today. Okay, so this would be our chapter 4. So we will be looking into the value of the money in the presence of future value and also present value, and then the interest rates. All right. So you might be familiar with this topic. So this is going to be just it might be a refresh, just a refresh, right? So let's begin. So in the chapter, of course, we're going to find out time value associated with money. All right. How the value of money changes as the movement of time. All right. So this is actually you can use this second point as the definition for future value. So determining future value based on number of periods over which funds are to be compounded at a given interest rate. All right. So how do you estimate? How do you forecast a future value of your money? Is based on the number of periods. All right. Whether your interest is compounded yearly, all right, is it semi-annually, is it monthly? So it depends on that. That's the number of periods, and of course the rate, the interest rate itself. So you need these in order to find out what is the future value. All right, the third point, of course, you can use it as a definition for present value. Present value based on current value of funds to be received. Okay, so let's say you're going to receive 5,000 in 2 years from now. 2 years from now, how much is it worth today? Okay, so you need to calculate the value today, it's present value. And of course, later I've already including the present value tables. All right, I will give you the present value tables, future and present value tables. Actually, the table consists of 4 items, which is present value, future value, present value annuity, future value annuity. So using the PV table, you can actually calculate most of the questions, all right, that involve time value of money, all right, and there are neat computations, determination of yield. So compounding or discounting occurring on a less than an annual basis. All right, so we will be finding whether the compounding occurs yearly basis or it could be less than yearly basis. All right. All right, so now we're gonna find out the relationship with the capital outlay decision. Determine whether the future benefits are sufficiently large to justify the current outlays. So one of the important aspects is you need to know when you make a payment or when you even want to receive something, when you're going to reflect that in the future benefits, is it justified? All right, if let's say you're spending 1,000 ringgit today, all right, you're investing 1,000 ringgit today, and in let's say 3 years, how the investment is going to give the benefit to you. All right, so you need to calculate how much the present value today will worth in future. Okay, so mathematical tools will help in making the capital allocation decisions. Right, so the capital outlay decision is usually, if let's say you want to invest in an asset, let's say you're buying a piece of land. All right, if you want to buy a piece of property, how it can give future benefit for the company or yourself. All right, so let's start with the first technique or time value of money, which is future value. All right, future value is single amount. Why I state a single amount? Because you have a future value annuity as well. All right, so this is a single amount. So the definition is measuring value of an amount that is allowed to grow at a given interest over a period of time necessary. All right, so you are giving, let's say you're investing 1,000 ringgit today, and let's say you're leaving in the bank for next 4 years, which gives you 10% interest per year, how much it would be worth in the future. All right, so that is the future value. You're giving some time for the investment, for the money to grow in value. All right, so if you're looking at the example here, let's say you're investing 1,000, assuming that the worth, okay, let's read the question. Assuming that the worth of 1,000 needs to be calculated after 4 years at a 10% interest per year. All right, we have, so the question says, let's say you're investing 1,000 ringgit today and you're leaving in let's say a bank for the next 4 years, that which gives you 10% interest. How much would it be worth in the future? All right, so first year you're investing 1,000, which gives you 10% interest. At the end of the year, you'll get 1,100. All right, so the beginning of the year you invest 1,000 with the 10% interest. End of the year you have 1,100. The next would be the second year you'll have 1,100, right, with the interest. So that will be compounding another 10%. So that will give you 1,210. So the third year is the same. The balance will be compounded and give you 1,331. And the last year, in year 4, again you have another 10% compounding. It will give you 1,464. So class, you're just investing 1,000 in the beginning. All right, that 1,000 compounding each year. All right, since you never took out the money, you leave the money there. So this increase of the 10% and so on. At the end of the year 4, you get 1,464. Right? So 1,000 is the present value. Why is it present value? Because you are investing today. All right. So the term present value means now. What is the value now? 1,000 ringgit you're depositing today. That means that is the value. All right, present value. And the amount that you receive after 4th year, that is the future value. All right. So present value, future value. In between, you have 4 years. That would be N, and also interest rate, which is 10%. So the entire process can be generalized in a formula, right? Because if it's 4 years, you can still sit down and calculate. What if it's 10 years? What if it's 20 years? What if it's 50 years? All right, you cannot be calculating one by one. So you need to come out with a formula. So this is the generalized formula whereby future value equals to present value in the bracket 1 plus I power of n. All right, so future value, present value, I is for the interest rate, n is for the number of periods. All right, so the exact example we just go through. All right, 1,000 is the present value because you're depositing today. Interest 10%, and it's 4 years. All right, so class, later on we'll be finding how we will change these to I and N, right? Because currently the question give you interest rate per annum. All right, so 10% per year. If they say semi-annual, it means twice a year. So we need to make some adjustments here. Same goes to N. Again, we need to make an adjustment if it's not annual. Annual means N equals to 4, right? But if let's say semi-annual twice a year, then your N becomes 8, right? So this thing sometimes we have to be careful. We need to read the question to understand carefully what the question really asking, right? So future value is what we're calculating, equals to present value 1,000, and then bracket 1 plus I, which is 10%, 1 plus 1 power of n, which is 4, you'll be getting 1,464. All right, so you could use your calculator to calculate All right, so class, remember in this time value of money you have two options. You can use your calculator or the formula to calculate, or you can use the present value table to calculate as well. So 1000, 1.464 equals to 1464 is exactly the same answer that you've calculated earlier. Alright, so class, if you're using present value table, alright, there is 4 tables as I mentioned earlier: present value, single sum, future value, single sum, present value annuity, future value annuity. So for this question, you'll be using future value single sum, right? So you need to look under the interest rate, which is 10%, and n equals to 4, so you'll be getting 1.464. All right, so you can take this amount directly and substitute in the formula, and you will get the answer, right? All right, so this is again the same formula: future value equals to present value times future value interest factor. All right, just now the formula 1 plus I power of n, right? That is called as future value interest factor. All right, let's do another example. Now you have 10,000 invested for 10 years at 8% interest rate. What would be the future value? So the first thing you have to do is, yes, 3 important items here. You need to identify these items. What value does it bring, right? 10,000 is it present value or future value? So you need to understand the question is future value, right? So it cannot be future value. And then they say were invested, so you can know this is present value, right? If you want to invest, you must have it now. So 10,000 is the present value, n is 10, right? And I is 8%. So how much? What is the future value? All right, so you can write the formula like this: future value equals to present value times future value interest factor, n equals to 10, I equals to 8%. Okay, this is how you usually start your calculation, by writing down the key inputs. All right, once you write down that, then the next thing is PV is 10,000 times future value interest factor is 2.159. Where you can get this? You can get this from the future value table, right? Since we're calculating future value, so you can get n equals to 10, I equals to 8%. This amount you can get it in your table, or you can use the same exact formula, which is 1 plus I power of n, 1 plus 1, and 1 plus 0, 8 power of 10. All right, so you'll be getting same answer. All right, class, remember, you might not get exactly same answer if you use 2 different methods, right? Sometimes yes, most of the times there will be slight changes, all right? Because PV table, they usually give only 3 decimal points, but when you use calculator, there could be 7, 8 decimal points, all right? So you might not be getting the exactly same answer. All right, the exactly same answer means there would be slight changes. Doesn't mean instead of 21,590 you'll be getting 20,000. All right, you might be getting 21,589.8, something like that. So there just be a slight difference, right? Okay, of course, since we have learned about future value, let's look at present value. Present value, single amount. A sum payable in the future is worth less today than the stated amount. Okay, so if I say I'll be giving you 1,000 in 5 years time, all right, is it the same value if I give you today, if I give you 1000 today and 1000 5 years from now, do you think the value is the same? Alright, the answer is no. $1,000, 1000 ringgit is more valuable today compared to say 1000 in 5 years from now. Right, so now we need to calculate how much the future value worth today. As I mentioned, $1 today is worth more than $1 1 year from now, 5 years from now. So someone says like, don't worry, I'll give you 5,000 next year instead of giving you today. Then you might need to calculate how much is it worth today, same 5,000, right? The formula for the present value is derived from the original formula of future value, alright, which means you don't need to remember two formulas. You can just use the previous future value formulas to decipher the present value formula, alright. So the present value will move here and the future value will move here. So it becomes present value equals to future value 1 divided by 1 plus I power n. Alright, so the entire thing goes below future value. Alright. So once you just rearrange the formula, you'll be getting present value equals to future value times present value interest factor. Alright, let's suppose we use the same example that we used earlier, which is the present value is 1000, investing for 4 years at a 10% interest. Now let's calculate the same thing let's calculate the same example by calculating the present value. Alright, so your future value was 1464. Your present value is, of course, you can use your table. Now use present value table. I equals to 10%. Alright, so class, okay, let's why don't you just beside here write down you are calculating present value. Alright, you're finding present value where the question give you n equals to 4, I equals to 10%, and future value equals to 1464. Alright, so let's say these information given, then you are asked to calculate PV. Alright, so 1464 given, n equals to 4, I equals to 10%. You can use your PV table to find this 0.683. So this times this, you will be getting 1000. As you can, alright, using PV table under 10%, 4 years, you will be getting 0.683. Alright, so let's look at the relationship between the present value and the future value. Alright, previously you deposit 1000, you leave it for the next 4 years at a 10% interest rate, you'll be getting 1464. Alright, if it works in the reverse where your future value is given and they say interest and is 4 years and is 4 is 10%, how much is it worth today? You can just calculate in the reverse. Alright, so this is forward, this is the backward. So 1000 increasing value into 1464, it's called compounding, and then the 1464 getting to 1000, it is discounting. Alright, so the present to future is compounding, from future back to present is called discounting. Okay. Alright, so let's move on to the next formula. It's called future value annuity. Alright, we have completed present value single sum and future value single sum. Now we look at future value annuity. All right, so annuity, you have to be careful. A series of consecutive payments are received of equal amount. So this is a key word that you have to look even in the question. All right, series of consecutive payments. Previously, we have just talked about one time. You deposit 1,000 one time, or you receive 1,464 once. All right, it's only happened once, one lump sum. But in annuity, it is more than once. All right, if let's say invest 1,000 means you invest each year 1,000, 1,000 year one, 1,000 year two, 1,000 year three, 1,000 year four. All right, so series of consecutive payments. It's not once, it's series. All right, of equal amount. So another important fact is it has to be equal amount. If I say 1,000 year one, 2,000 year two, 3,000 year three, you no longer can use this future variability. It has to be equal amount. Let's say 1,000 means next 2 years is 1,000. Only then you can able to use the formula. All right, the future value of each payment can be total to find the future value of an annuity. All right, let's take an example here. Assuming your annuity is 1,000. All right, so plus annuity means the A here means a consecutive payment of equal amount. All right, this amount is basically repeated for n equals to 4 means for 4 years. Each year you are investing 1,000 at I equals to 10%, your interest is 10%. So let's find out how much is the future value annuity. All right, so future value annuity, you're still calculating how much is it worth in the future. All right, but since the amount is repeated, we call that as annuity. So instead of writing FV, you put FVA. All right, so your annuity is 1,000 and your future value annuity into expected. So class previously FV, IF, right? Now you have IFA, which indicates this is the annuity example, annuity question, right? So instead of using future value table, you will be using future value annuity table to calculate this. So 1,000 times 4.641, you'll be getting 4,641, right? All right, so you can use the future value annuity table where 10% n equals to 4, you can find this amount. So let's see how the compounding really works. All right, so in the beginning you invested 1,000. All right, so in the beginning you invested 1,000. In year 2 invested another 1,000. Year 3 another 1,000. Year 4 another 1,000. All right, in period 1 when you invest 1,000, you are leaving it for next 1 year, 2 years, 3 years. All right, so you invest in year 1 and you leave it until year 4. So you have 1, 2, 3 years for compounding. All right, so 1,000, if you use n equals to 3, I equals to 10%, you'll be getting 1.331. All right, so this is compounding 2 years. This is compounded for 1 year, and the last year, the amount that you have invested, there's no longer any time left for you to compound. So 1,000 remains 1,000. All right. So this period 1, 2, 3, 4. If you add up all together, you'll be getting 4,641. Right? So instead of calculating one by one, you could just use the formula to calculate the total amount. Right? Alright, so let's look at the present value annuity. So calculated by discounting, right? So when it's present value, you use the word discounting to find out whatever the future value, how much is it worth today. All right. So again, annuity 1000 n equals to 4, I equals 10%. So instead of calculating future value, all right, so now we're calculating present value. All right, so it's similar when it comes to about working. It's similar. All right, instead of future value annuity, now you have present value annuity equals to annuity times you have PVIFA. All right, because it's a present value annuity interest factor. So now instead of using any other tables, you need to look for present value annuity table, and you look for n equals to 4, I equals to 10%, you'll be getting 3.17. So 1000 times 3.17, you'll be getting 3170. So what does it mean? Even though you invest 1000 year 1, year 2, year 3, year 4, that is worth only 3170 today. All right, so that is the value today. So let's look at the relationship. All right, so let's the relationship between present value and future value, the relationship with the present value single amount, and also annuity, and what are the future value related to the future value annuity. All right.